All right, so there's a couple things here just definition-wise that we want to look at. So triangles can actually be named by the type of triangle as well as their angles. So a triangle with all equal sides is an equilateral, so that means all the sides have the same length. A triangle with two sides the same, isosceles, iso, meaning two or more the same. A scalene triangle is a triangle where all sides are different lengths, all right? So equilateral, same length. Isosceles, two or more, and scalene are all different lengths. Then we can also talk about angles. So a right angle triangle, a right triangle has one right angle in it, and that right angle means that it has a 90-degree measure, all right? And that's always indicated with a box in that angle. So that is a 90-degree angle that we see there. An obtuse triangle is a triangle in which the angle is greater than 90 but less than 80. So our obtuse triangle is one that has at least one obtuse angle in it. And that obtuse angle is more than 90 but less than 80. So that would be our angle here, our obtuse angle. And then we also can have an acute triangle. And I always remember this as an acute, so cutie, acute triangle. So an acute triangle is when all three angles are acute. And an acute angle means that it's more than 0 and less than 90. So our acute here, they're less than 90 and greater than 0. And then the last angle that we see here also, just so we've got our angles defined, our last angle here is a straight angle. And a straight angle means that it's exactly 180 degrees. So a line has a straight angle. We also want to make sure we're comfortable with names of different types of polygons. So the most common one is a triangle, which has 3 sides. A quadrilateral, or 4, so quad is 4 sides. Pentagon is 5, right? So pent means 5, and then gon. So polygon, many sides. Pentagon means a 5-sided. Hexagon is going to be a 6-sided. Heptagon is a 7-sided, and an octagon is an 8-sided. So we just want to be able to make sure that we're comfortable with these classifications for triangles and for our polygons. So then here, if we're looking at A, fill in the missing information. So a triangle with 3 unequal sides, well, that's going to match our definition for a scalene triangle. An obtuse triangle has one obtuse angle, right? We looked at our definition there, one obtuse angle. A triangle with at least 2 equal sides, well, by definition, that's going to be our isosceles triangle. A triangle with 3 equal sides, well, that was our equilateral triangle because all of our sides are the same. A triangle with at least with one 90-degree angle, well, that's our right triangle because that 90-degree angle in there makes it a right triangle. A polygon with 5 sides, well, let's see here. If we've got a polygon that has 5 sides, that is a pentagon. And then hex, so hexa means 6. Hexagon has 6 sides. So we just want to make sure that we are comfortable with these classifications for triangles and for our polygons. One other thing to note here is that we can actually find the measure angle, the missing measure angle of any regular polygon, and that formula is always going to be 180 times n minus 2. And so n equals the number of sides. So the number of sides minus 2 times 180 is the sum of all of the measure angles in any regular polygon. So let's take a triangle, for example. We know that a triangle has 180 degrees in it. We also know that a triangle has 3 sides. So let's test out our formula. 180 times 3 minus 2, well, that's 180 times 1, which equals 180. So we're showing here that this formula will always work. So find the sum of the angle measures of each of the following. So a octagon, we said, has 8 sides. So we want to take our formula, 180 in minus 2. In here is equal to 8. So 180, 8 minus 2. So 180 times 6. And that should give us the sum of all those angles. So 180 times 6, and that is 1080. So there is a total of 1080 degrees in an octagon. And we can do that same thing here for our 15-sided polygon. So write our formula, 180 in minus 2. In here is 15. So 180, 15 minus 2. So 180 times 13. And that's going to give me 2,340 degrees. So this formula, 180 times n minus 2, will work for the sum of the angle measures for any regular polygon.